In this module, we will cover fundamental aspects that designers need to keep in mind to ensure a successful import into GeneXus. Although most specific adjustments will be made in stages after the design phase, it's important for us as designers to keep certain general considerations in mind that will simplify the integrator's work, especially regarding design aspects and decisions. We will focus on two key aspects of the design process: componentization and systematization. This approach not only helps us organize our work more effectively, but it is also essential for an optimal import into GeneXus, supporting the maintainability and scalability of the system. Let's start with components. Why is it important to use them efficiently? Using components in Figma allows us to create reusable elements that maintain consistency throughout the design. These components act as templates, defining a set of elements and properties that I can instantiate as many times as needed. On the other hand, component instances are adapted versions of the original component that are used in specific situations, allowing you to customize data, such as changing text and images, adjusting a state, hiding or showing elements, or modifying colors. Additionally, GeneXus supports the use of external libraries, but it's important to keep in mind that these libraries need to have the specific adjustments required for proper interpretation by GeneXus. Otherwise, an optimal import won't be possible. If you're working with components from external libraries that don't have these adjustments, our recommendation is to make those components local and adjust them so you can use them. A good practice we recommend is to keep the components on a separate page to centralize them and prevent them from being spread across different pages of the file. Designing with components correctly not only saves time, but also makes it easier to modify styles and properties across multiple instances of the same component. For example, instead of designing a different button for each section, we can create a single button component to use throughout the entire application. Now, what happens with these components and instances in GeneXus? Going back to what we discussed in the previous module, every element in our design will have at least one equivalent in GeneXus. Most of the elements we define as components or component instances will correspond to the stencil object and the stencil control instantiated in the panels. It's important to clarify that there are some limitations to keep in mind. For example, if I have a vector graphic defined in a component that represents an icon, and that component is exported as an image, if I change the color in an instance, then GeneXus won't be able to interpret that modification. This happens because for GeneXus, the parent component is an image, so it ignores the color change in the instances. To solve this kind of case, the best approach would be to use component variants, which we'll go into more detail about later. On the other hand, it's essential to make good use of components. Overusing components and instances can create complications for the maintainability of the project. For example, we've often come across designs that turn elements into components when it's not necessary, like a piece of text. Let's look at this using the example of a card. In this case, the component is the card as a whole. This element will be used more than once across several screens in the application. If I designed each element within the card as a separate component, I would end up with an excess of components, which in this case is unnecessary and only adds more elements to maintain and import into GeneXus. Let's see the difference when importing one file versus the other. You have to think of components as atomic units, but not as single units. Another very common mistake is creating a component for every button and not using overrides and variants correctly. Let's look at two examples to make this clear. When I have a case where a button changes its size or caption throughout the application, I don't need to create a separate component for each button. The parent component remains the same. It defines the shape, the position of the text, the typography, among other properties. And in the instances, we make the necessary changes, using good judgment. On the other hand, when I want to set, for example, button states, it's appropriate to use variants to define the style of each one, not a separate component for every state. This will give us more organization and consistency in the file, and make the GeneXus knowledge base easier to maintain. When we say it's necessary to use good judgment when overriding a component, we mean that we need to be cautious when making changes. If, when instantiating a component, we override almost all of its properties in terms of shape, color, position, and typography, we wouldn't be respecting the concept of overriding because there would be no similarity with the parent components. In this case, we should consider creating a new component instead of modifying an instance. In conclusion, we can say that properly componentizing elements is essential, since it allows us to have more organized and efficient files, as well as making it easier to maintain Genexus objects. If we manage to properly structure our file, the maintainability and scalability of the project, both in terms of design and implementation, will increase considerably. Now, let's move on to the second point, systematizing the design. Why is it important to create our files with text and color styles? Defining text and color styles in a centralized way is essential for applying these styles consistently throughout the application. By doing this, we ensure a uniform and professional look. Within text styles, we can establish hierarchies that will be used across screens, such as titles, subtitles, headers, paragraph text, and button captions, among others. Each of these styles can be assigned a set of text properties that we consider appropriate, allowing us to have a repertoire of text styles within the same file. The same goes for the color system. We can predefine the palette to be used throughout the project, establishing hierarchies through color styles. The most significant advantage of using styles is that if we need to make a change, for example, adjust the font size or change a color, we only have to do it once in the corresponding style. And this adjustment will automatically be reflected everywhere that style has been used. It's important to note that although we'll talk more about layer naming later, it's essential to keep in mind from now on some considerations that apply both to styles and to the layers on the file. It's recommended to use semantic names and avoid default names, clearly describing what each style represents and collaborating with the developer to establish a naming convention. Use alphanumeric characters for names, always starting with a letter and removing any leading or trailing whitespace. Keep names concise but meaningful and avoid duplicate names for components, layers, and styles. If there are duplicate names, when imported into Genexus, numeric suffixes will be added automatically. For example, button, button 1, button 2, and so on, which compromises the maintainability of the application. In conclusion, defining text and color styles in Figma helps maintain a consistent look throughout the design. By systematizing these elements, you reduce the chance of errors and ensure that all texts and colors are imported correctly into Genexus, making it easier to implement and maintain the design. Up to this point, we've clarified the importance of designing while keeping in mind that the final file will be imported into Genexus, and how essential it is to work through this process by strategically using both components and text and color styles. In the next module of this unit, we'll talk about best practices to consider when designing a project for import.